Hello, and welcome to Dakota Prep's video tutorial on sizing conductors for transformers. Okay, now in this case, it looks like we have primary protection for this transformer, and we've got this question here. It says, what are the minimum size THW insulated copper conductors permitted to feed the primary? It is a feeder. Feed the primary of a 75 kVA 480 to 208 volt, so 480 volt primary, 208 120 volt, that'd be a Y secondary transformer. So that means it's three phase, right? 208 120 volt. The only way we're getting those voltages, that combination, is with a three phase Y configuration, where the transformer is protected from overcurrent protection by a 225 amp breaker. Okay, so the good news is pretty easy. Pretty easy question here, okay? And it's pretty easy because of 240.4. 240.4 says, hey, conductors shall be protected against overcurrent protection in accordance with their ampacities, right? So that means that the ampacity of our conductor has to be protected, right? Now there are a couple of other rules in there. In fact, right there in 240.4, 240.4b says, well, if your conductor ampacity doesn't correlate with the standard size overcurrent protected device, you can go up to the next overcurrent protected device in general, but there's some situations where you can't. Okay, for this one though, pretty straightforward. We cruise to everyone's favorite table, the infamous and famous Table 31016. It says we've got THW conductors. We go find THW conductors. Okay, turns out right here, THW conductors are rated for 75 degrees Celsius. We're in a 75 degree column here, 75 degree column. Are they copper or aluminum? It says we've got copper conductors. Okay, we are in fact in the copper columns, the three copper columns section. Right, with aluminum and copper clad being toward the right, or table 31016. So we're in our 75 degree column of our copper columns, right, because we have THW conductors. Now, we need conductors that can handle 225 amps, right, because that's the size overcurrent protection that we have. And according to, like I said, 240.4, our conductors have to be protected at their ampacity, right? So we need conductors that can handle at least 225 amps. We cruise down our column here. The 3/0 won't quite get it done. Looks like 4/0 is going to be our green ink correct answer.